we present Cogment Verse, an open-source human-in-the-loop learning and multi-agent reinforcement learning research platform. Let's talk first about what human-in-the-loop learning is. After that, we'll explain the challenges associated with the human-in-the-loop learning method and how they are addressed. Finally, we will feature some applications. Human-in-the-loop learning is about training AI agents by having them interact with humans. The objective can be to leverage human expertise or to train agents to collaborate or compete with humans. Traditional supervised learning techniques can leverage human expertise in the form of annotations, but their offline nature means that the annotations need to cover the combinatorial space extensively, which can be costly. By having humans in the loop during training, they can cover the most relevant part of the input space. These techniques require less data because humans' interactions are contextual to the training process. Cogment Verse focuses on sequential decision-making, traditionally tackled with reinforcement learning techniques. Let's take, for example, the classical Atari game of Pong. To train an AI agent to play Pong, you're likely to use self-play training. We are currently observing an agent training against itself in the Cogment Verse web client, which wraps around Petting Zoo's Pong environment. If you want to train an agent to be fun or competitive, you will need to train it or at least validate it against human players. Cogment Verse allows you to run episodes involving your agent and a human player in the same way that you run self-play episodes. A bunch of human-in-the-loop learning techniques leverage demonstrations of how humans play the game or of how humans perform the task. Human demonstration can accelerate the training process with everything from behavior cloning approaches to algorithms like Dagger. Cogment Verse allows you to use this data in the same way that you would use experience replay data coming from the agents. Cogment Verse also supports having the human player dynamically take over control of the paddle from the agents at any point during the episode to get in-context demonstrations. Another approach is to leverage humans as evaluators who give feedback to the training agent. Such feedback can be used directly in a reward or indirectly to train a model of the reward function, such as in the Tamer algorithm. Cogment Verse is built upon Cogment, an open-source platform designed to address the challenges of building and operating human-in-the-loop learning systems. The first of those challenges is interoperability. Thanks to its distributed microservice architecture, Cogment is able to execute episodes over any kind of simulation or agent decision-making and evolve any kind of interactive application. The second challenge is the limited availability of humans. Unlike AI agents, humans are not available 100% of the time and can't operate faster than real time. Thanks to its fully asynchronous orchestration, Cogment doesn't stop training while waiting for the humans to be available or to decide on the next action. Because of its ability to be deployed on the cloud at any scale, Cogment is also well suited to leverage large crowds of humans. A third challenge is the cost of acquiring human data. Because Cogment episodes are configuration-driven, it is really easy to have a mixed training curriculum involving both interactive episodes and headless ones. Thanks to its unified data store, Cogment enables the training process to leverage online data as it is collected and also mix in valuable historical data. Cogment is a very powerful platform for industrial applications, but it can be intimidating. That's why we built Cogment Verse, which is designed for researchers. It builds upon the familiarity with OpenAI Gym. Cogment Verse comes built-in with a growing collection of environments starting with Gym and Petting Zoo. Any environments using Gym spaces and that is able to render to a picture can be turned into an interactive Cogment Verse environment. To implement an agent and its training process, Cogment Verse requires you to implement 4 components: a serializable model that will be used for storage and distribution during the training, an actor that is in charge of taking actions during the episodes, a sample producer used to produce training samples from the raw data stored by Cogment, and finally, a training runner that will schedule interactive and headless episodes as well as leverage recorded episodes to train and evaluate the agent's model. Cogment Verse relies on Cogment to orchestrate and distribute this centralized training, decentralized execution training loop. It also provides reference implementation of common human-in-the-loop learning and multi-agent reinforcement learning techniques. Cogment and Cogment Verse have a growing community of academic and industrial users that are doing very cool research in the field of human-in-the-loop learning and multi-agent reinforcement learning. You can join the community by downloading Cogment Verse from GitHub and join our Discord server.